Oh, okay. So we were showing that theta is on to. Theta is on to. Theta is on to. So actually, what we have to show, we have to because so we have to show that we have to show that. So we need to show that every ideal in S over I is of the form from J over I, where J is an ideal of S containing I, where J is an ideal of S containing I, because थीटा जो मैपिंग है वो A से B पे है और थीटा किसी भी J को किसी भी आइडियल J को मैप कर रहा है J over I पे। तो हमें हमें और B क्या है? B है सेट ऑफ आइडियल्स ऑफ I। तो ऑन को दिखाने के लिए हमें दिखाना पड़ेगा कि हर कोई एलिमेंट B का हमें दिखाना पड़ेगा हर कोई एलिमेंट B का J over I फॉर्म का है। दैट्स इट। ओके तो कोई भी आइडियल आप लो, सो लेट K बी any ideal of S over I, then K would be actually consisting of elements, because elements of S over I, they are classes, they are actually row I classes. So K would be actually consisting, so it is actually Xi, such that X belongs to say S dash, and S dash is a subset of S. S dash is a subset of S. ओके तो हमें दिखाना है K जो है K should be of this form. K should be of the form J over I, where J contains I. So for that, let J equal to X, those X's for which Xi belong to K. Okay, J is equal to those elements X for which Xi belongs to K. Easy to show that J is an ideal. Easy to show that J is an ideal of S. J is an ideal of S and it contains I, containing I. How? Because if you take X is in J and some element S in S, then if you take the product Xi, Si, and this product is same as XSI. Okay. Now XSI belongs to K. Okay. Because Xi is an element of K and K is an ideal. So Xi product Si is an element of K. But see the definition. Definition is J is those X for which this is in K. If this is in K, then this means that This xs belongs to J. Xx belongs to J. Similarly, Sx belongs to J. So J is an ideal. Okay, so this means J is an ideal. Okay, and J contains I, because suppose if I take A in I, then AI, which is equal to I, and I belongs to K. So this means A belongs to J, and this shows that I is a subset of J. So thus, what I get here is that K is nothing but J over I. Okay, K is J over I. So showing that theta is onto. Showing that theta is onto. Inclusion preserving is also clear. So clearly theta
सर
is
कुछ स्टूडेंट्स वेट कर रहे हैं सर.
है, वेट कर रहे हैं.
कुछ स्टूडेंट्स जी सर.
ओके, मैंने कर दिया उनको. So theta is clearly theta is inclusion preserving. Why? Because if I take J1 subset of J2 and I take say xi belonging to say J1 over I, this would actually imply that x belongs to J1, but J1 is a subset of J2, so this means actually says that x belongs to J2, and this would say that xi belongs to J2 over I. So J1 is a subset of J2. It implies that J1 over I is a subset of J2 over I. So therefore theta is inclusion preserving. Okay, so this was a proposition. This was actually a brief about ideals and these congruences. The next topic is actually lattices of equivalences and congruences. Lattices of equivalences and congruences. Lattices of equivalences and congruences. And मैंने आपको पहले ही बताया था व्हेन वी वर डिस्कसिंग कॉन्ग्रुएंसेस, जब हमने मीट और जैन की बात की थी वहां, तो हमने देखा था कि द सेट ऑफ ऑल कॉन्ग्रुएंसेस ऑन ए सेमी ग्रुप एस इज ए लेटिस वेयर, so we have seen that, so we already know that this CS, the set of all congruences on a semi group S, the set of all congruences on a semi group S is a lattice, is a where What was the meet where for any rho and sigma in CS, rho meet sigma is actually the intersection, rho intersection sigma, and rho giant sigma is nothing but rho composition sigma infinity. Okay, so it's a lattice. We have also seen that this we have also seen that if the congruences commute, if rho composition sigma is same as sigma composition rho, then this giant is nothing but the composition. Then rho giant sigma is nothing but rho composition sigma. Okay, the next result actually says that this is always true in case of groups. If the semigroup is a group, then the join is always composition. Why? Because in groups you have this property that the composition commutes. So this is a very nice result about groups. If G is a group, if G is a group, then rho composition sigma is same as sigma composition rho for any two congruences sigma and rho on G. For any two congruences sigma, for any two congruences rho and sigma on G. So thus rho giant sigma is same as rho composition sigma. No, see the proof. But for semigroups, you don't have this property that rho for semigroups other than groups, this property is not in general true. To show that these are same, we just have to show that this is contained here and this is contained here. Let A comma B belongs to rho composition sigma. Then there exists some C in G such that A comma C belongs to rho and C comma B belongs to sigma. Okay, C comma B belongs to sigma. So it follows that if you take A, because we are in group, so you can write A as C inverse A, and this is congruent to B C inverse A mod sigma. mod sigma, क्योंकि आपके पास क्या है, आपके पास है C is congruent to B mod sigma, है ना. ये जो आपका C कम B बिलोंग टू सिग्मा है, इसको आप ऐसे भी लिख सकते हैं C is congruent to B mod sigma. इसका मतलब ये हो गया C is congruent to B mod sigma. और ये कॉन्ग्रेंस है तो आप ये लेफ्ट कंपैटिबल भी है, तो आप सी इनवर्स से दोनों तरफ प्रोडक्ट कर सकते हैं सी इनवर्स ए के साथ. So you get that C inverse A is congruent to B C inverse A mod sigma. Similarly, and B C inverse A is congruent to B C inverse C. B C inverse C mod rho. क्योंकि आपके पास यहाँ है A is congruent to C mod rho, तो आप लेफ्ट साइड से बी सी इनवर्स को प्रोडक्ट कर सकते हैं बाई लेफ्ट कंपैटिबिलिटी, which is actually equal to B, which because this C inverse is equal to this, so which is equal to B mod rho. तो आपके पास क्या आ गया? इन अदर वर्ड्स आपके पास आ गया है A कामा B C इनवर्स A belongs to sigma, and इस रिलेशन से आ गया आपके पास B C इनवर्स A कामा B belong to rho. Therefore, combining the two, I have A comma B. A comma B belongs to sigma composition rho. So you can say that rho composition sigma is contained in sigma composition. Sorry, rho composition sigma is contained in sigma composition rho. Now interchanging the roles of rho and sigma, interchanging the roles of rho and sigma, we may equally well show the opposite inclusion. We may equally well show the opposite inclusion. So we have the result. The result follows. The result follows. Okay. So I think we have enough for today. We will discuss tomorrow now. If you have questions, you can raise. Okay, so if you have no questions, then CR आप attendance लेके मुझे भेजो. आप
यस सर.
हाँ इसमें वो लिखना डिटेल्स पूरा है.
जी सर.
ओके, थैंक यू.